on the class website. Okay, so as I was saying, 7.7, essentially what we're doing is we're solving nonlinear systems of equations. So imagine instead of the systems of equations that we did in the past, and you don't need to write this down, but just showing you. Instead of solving something like that, essentially what we're going to solve in this chapter, or in this section, is something like y equals 5 over x and y equals 6 over x plus 2. Okay, so solve that system of equations. That's essentially what we're doing in 6.6, except they're word problems, so we need to first write those two equations, and then how would we solve that system of equations, right? Remember we have three methods. We have addition, elimination, graphing, or substitution, right? Which one looks like the most tempting method to solve?
Substitution?
Yeah, right? Because we would say, well, y equals 5x, let's put that in for y, and we would get 5 over x equals 6 over x plus 2. So that's how we're going to solve this, and then from there, how would we solve that, just to review? What was it?
Does that same? Well,
Yeah.
we'd have to find LCD.
Find LCD,
Yeah.
and then
Multiply, and then
Yeah.
same thing.
find LCD, multiply by the LCD, no more fractions, solve it like we did in past chapters. Okay, so that's the big idea. So we're going to get two equations that look like this, y equals something and y equals something, then we're going to use substitution, set them equal to each other, and get an equation that looks like this. All right, so this is 7.7. The math title of this sounds very generic. So applications using rational equations. In other words, word problems. That's what applications means. With polynomial fractions. Okay, for numbers 1 through 10, which these are the big ones we're going to focus on, 10 word problems at the beginning, it's one big formula. Rate times time equals distance. But of course we could rewrite that in terms of any variables. So we could write it as rate times time equals distance. Or if we wanted to solve for rate, how would we write it in terms of rate?
Times over distance,
Let's not guess. How would we solve this for rate?
divide by time.
Divide by time. So we divide both sides by time and we would get rate equals
Time with distance.
Distance over time.
distance over time. We divide both sides by t and we would get distance over time. Okay? Or that's distance equals or rate equals. What about time equals? Right? How do we solve for time?
Multiply.
Well, we want to solve for t. We got this equation right here.
Subtract r to the other side.
That would be if there's a plus sign there. That would be the inverse operation. But what sign's there?
So divide by r.
Yeah. Divide both sides by r. The r's cancel out. We get t equals distance over rate. And by far today, this is going to be the equation we use the most. Okay, so the same equation, just solved for three different variables. We're going to use that time equals distance over rate the most. All right, so let's just jump straight into the examples. Here's the example, okay? A motorcycle can go 40 miles in the same time a bike can go 15 miles. The motorcycle is traveling 20 miles per hour faster than the bike. Okay, find how fast each of them is going. Right, so I'm gonna write this one a little more expansively, and then the other ones I'm gonna make a little table. Okay, so for this one, what I wanna do is I wanna look at what's the distance that the motorcycle travels. What's the distance the bike travels? Then I wanna say, okay, well, what's the rate at which the motorcycle travels? What's the rate at which the bike travels? And then what's the time it takes the motorcycle and the time of the bike, right? And on the next problem, I'm gonna write this as a table. So, what do we know?
The motorbike can go 40 miles
Mm-hmm.
In the same time.
as the bike goes 15.
Yeah, so the bike goes 15 miles, you guys said something else.
So the time would be equal on both sides.
Exactly, that's the big thing. This being equal, that's important. That's where I was telling you that system of equations, y equals 5 over x, y equals 6 over x plus 2. This is gonna be time equals, and then you're gonna set them equal to each other since those two times are equal. Okay? Anyways,
Rate for the motorbike would be 20.
not 20, because we don't know its rate. We don't know it's 20, what do we know?
Times
It's
20.
20 miles per hour more,
It's 20 miles per hour more than
20 the bike.
the bike.
How will we represent the bike? 20 plus x, no, 20 plus b?
Sure, so what, for what? Just be a little more specific, like a full
Rate.
sentence.
Rate for the motorcycle would equal b plus 20,
Okay,
and rate for the bike would just be b.
perfect, okay. Or you could have said the rate for the motorcycle is x, and this one would be
X.
Plus 20.
X minus 20.
minus, right? It'd be
Oh,
20
minus,
less,
okay.
right? So it doesn't matter which one you call the variable, the relationship you have is that this one's 20 more. So it could be x and x plus 20, or x and x minus 20. I like using a letter like b or n though, so you know which you're talking about. Alright, so now what we're gonna do is we're gonna write out an expression for time, and we're gonna do this on every problem. Okay, now remember, this expression, or the equation we have, the formula we're gonna use is time equals distance over rate. So how would we write out what the time it takes the motorcycle is? Okay, and we know these are equal. Okay, so how long did it take the motorcycle? Write out an expression. A hint, it's gonna have x's on the bottom because that's the entire chapter we're working on right here.
So b equals 40 over b plus 20.
Exactly, 40 over b plus 20, and what's the bottom one?
15 over b,
There we go,
or 15 over r minus 20.
yeah, there we go. Okay, that's what we're gonna use, and as it's still circled, they're equal, as I think that was Luis that said that. So I'm gonna set that up right here, just continuing the problem. What would be the equation we are gonna solve now?
15b equals 40 over b plus 20.
Exactly, so 15 over b equals 40 over b plus 20. Okay, so in general, Alright, so to get your equation in general, things are gonna happen in the same amount of time. So you're gonna write an expression for the time it takes the first vehicle, the expression it takes for the second vehicle, and then you're gonna say, well, they took the same amount of time. So I'm gonna say this time equals that time, and there we go, there's our equation, right? And now we can solve like normal, okay? So what will we do first? Let's go with Sarah, you've been quiet lately, what should we do? And Dan, you're coming up next. Yeah,
Times both sides by b parentheses b plus 20.
exactly, that's the LCD. And over here, same thing. Okay, so cancel, 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 cancel. We get, there's more space over here. We get 15 times b plus 20 equals 40b. And then we just solve it like normal. So that's 15b plus 300 equals 40b minus 15b minus 15b. We get 300 equals 25b. Divide by 25, divide by 25. b is 12. Okay, I'm not going to put a box around that because it's a word problem. So always at the end of a word problem, I reread it. Alright, what's it asking for?
Miles per hour. How fast they're going? So the bicycle is traveling 12 miles per hour,
Yeah,
while the motorcycle travels 32 miles per hour.
exactly. So you need two speeds. Units are great, but really the big thing is you have to have two separate speeds and you need to identify which is which. You can't just say x equals 12 or 12 comma 32. You need to say bike equals 12 miles per hour, great, but at least bike equals 12, motorcycles 32. Yeah,
Can you, on the 40 over b plus 20, can you like cross out 20 and 40 and like make it smaller?
good question, good question. Can you cancel one part of this group with something on top?
Yeah, no,
No,
Yeah,
there's a whole term.
just make it.
It's a group, man. Math is like the gnarliest game ever. You can never, ever, ever mess with a single part of a group. Never, ever,
That's
ever.
a small, because that's a group.
Yeah, it's a group.
Right?
It's because you have this division bar, horizontal lines in math. I mean, it's a group. So this is absolutely a package deal. You can never, ever touch any one part of it without affecting the entire thing equally. Right. Yeah. Okay, this is good. Let's do another problem that's exactly the same.
How did you get 32 miles per hour?
What about, how do we get that? Oh,
Well,
great.
was it at 20, right?
Yeah, we went right back here and we said, well, if this is 12, then the rate for the other one is 12 plus 20. Good question, good question. All right. I want to come in here with a terry cloth today and just clean this board white. Okay. Whew. All right, so number 4, pretty much the identical problem. All right, this time it's a car and a truck. So a truck travels 120 miles in the same time. A car travels 180 miles. Okay? Truck is going 20 miles per hour slower than the car. I'm leaving out tons of words here, sorry for my terrible English. And then find their speeds. Alright. So the big hint here is it can be helpful to make a table. That way you're always finding all the information you need and it's organized neatly. So I would say, okay, here's my distance, here's my rate, here's my time, and here's my whatever it is. In this case, it's a truck and a car, alright? Now in general, we're gonna find out for distance and rate what information we have, and then time is gonna be some fraction with x's on the bottom, or whatever variable you use. Okay, distance they traveled.
Which one was for the truck?
For the truck, 120 miles, yeah. 180 for the car. And the rate for the truck?
20 minus 20.
20 minus whatever variable you wanna use for.
C minus R.
Let's think about that. If the car is going 30 miles per hour, then this would be negative 10 miles per hour. What do you want? You want 20 miles per hour slower than this. So you want to start with x and then take away the 20. So write information but just off by a negative sign. So 20 miles per hour slower, you want to start with whatever variable you use for the car speed and say 20 miles per hour less. Okay? Alright, so what's our expression for traffic? How much time did it take? Remember that formula we've got? And I always could use units if you want to say, shoot, is it rate times what times equals what? I always use units to get a nice basic one. Here's any units, miles per hour, so times time equals, well, hours and hours cancel out, equals miles. So there we go. This is a rate times a time equals a distance. I always use units to double check my formulas, make sure I didn't mess up, because I switch things so often. You guys see it on the board, I wasn't switching things. Okay, so time. What do we got with the expression for the truck?
So time would equal 120 distance over the x minus 20.
Yeah.
The bottom one for the car would be 180 over x.
Exactly. So now that we've got these, there's one golden piece of information in the word problem that we're going to use, which is,
Find their speeds.
well, that's what we're going to find, but there's one piece of information in there that we really like.
The same time.
Yeah, in the same amount of time. And this is what we're going to use to make our equation. Okay, that's our equation. So what's our equation now?
T equals.
We don't need the t equals, because we already got time equals, we already wrote that. Right, we know they happened in the same amount of time, so we can say the time the truck took and the time the car took are the same, so,
And then equal sign.
yeah, equal sign then,
120 over x minus 20
Yeah.
equals 180 over x.
yeah. So this is the time it took the truck, and that's equal to the time it took the car, right? And that's the big idea, is we know they happen in the same amount of time, so that's how I can say this equals this. Alright, and then it's always the same strategy to solve, right? Miguel, how would I solve that?
The LCD,
Yeah, which is?
x minus 20, or x parentheses x minus 20.
Exactly, so the LCD, because they're two totally different things, is x times x minus 20, and then?
And then you multiply.
Yeah, just multiply everything by that LCD. Here's x times x minus 20. Here's x times x minus 20. So, x minus 20's cancel, and we get 120x equals, the x's cancel, 180 x minus 20. Right, and you solve like, nice cool trick you could do here, which you don't have to, is you could divide both sides by 10 right now. You can even divide both sides by 60 right now to make things easier. That's awesome if you see it, but whatever. Okay, so multiply, we get 120x equals 180x minus 3600, whatever, calculate it. No worries. Minus 180x minus 180x. We get negative 60x equals negative 360, divide by negative 60, we get x equals 60. Okay? Never just box x equals 60 and say you're done. So,
The car is that, right?
yeah, so,
The car is 60,
yeah, so the car's going 60 miles per hour, okay?
and then the truck's gonna go 60 minus 20, so it's truck's gonna go 40.
Exactly, so the truck's going 40 miles per hour, and you could just plug it back in, see if you can plug it back in, sure, it works. Go back to the story. Okay, a truck travels 120 miles. Well, if he's going 40 miles per hour, that's 3 hours. Okay, a car travels 180 miles. Well, at 60, that's 3 hours. So 3 hours equals 3 hours, same amount of time, awesome, difference, right? Truck's going slower, right? Everything checks out, right? So you can go right back to the original and see if it works. Okay, so that's it. I'm gonna add one wrinkle by going to number 10, and we're gonna stop there. There is a second type of problem in there dealing with similar shapes. I'll leave that up to you guys to solve. I don't wanna overload you. I wanna give you about half hour, 45 minutes to work on the practice test today. So let's do one last type of problem. This type of problem, again, is the same. The difference is a little concept having to do with wind adding speed to an airplane, or water adding speed to a boat or slowing the boat down. So in this, it's a guy on a canoe. Alright, so number 10. Alright, says a water's current is 2 miles per hour. Alright, it says a canoe can travel 6 miles downstream in the same amount of time it takes to travel 2 miles upstream. Okay. What is the canoe's speed? In still water. Okay, so we're gonna do this the same way. We're gonna set up a table. We're gonna say, oh look, it's in the same amount of time, so we're gonna write two expressions for time. We're gonna set them equal to each other. It's gonna be polynomial fractions multiplied by the LCD. Everything's the same. There's one little concept that's new. And that's this whole water current still speed thing. So let me just get physics on you for a second. Alright. So imagine this canoe enthusiast is canoeing in the middle of the lake. Okay, and this canoe can move at some speed. Okay, whatever that still water speed is. Okay, let's say their still water speed is 5 miles per hour. Okay, in still water, right? So you can paddle at 5 miles per hour. Now, if that chunk of water that you were paddling in, right? So you're going at 5 miles per hour relative to that water you're sitting in. Well, let's say that water you're sitting in is moving down a river at 3 miles per hour. Well, then your combined speed now, because you're still paddling on the water you're sitting in, you're moving 5 miles per hour in that water. And then that entire chunk of water is moving with you, so you're going extra fast. Now you're going at, add these together, a total of 5 plus 3 equals 8 miles per hour. Right? The way I think about this, I've done a lot of airports and flying in the last couple of years, and think about those like walkways that I still have no idea why they put those in there. Like you're in such a rush that you need to get that 100 feet and save like 4 seconds. But you know, whatever, it's a lot of money just for fun. So if you're walking and you're in a rush, there's that like, you know, conveyor belt, and whatever your walking speed is, say like 3-4 miles per hour, if you step onto that conveyor belt, you're still walking at the same speed, except for the lazy people, who just get on the fast thing just to stand there, right? And that's even crazier. But if you're walking at 3 miles per hour and you step on the conveyor belt, now you're going 3 miles per hour plus however fast it is moving you forward. So now instead of 3, you're going 3 plus 2, 5 miles per hour, right? So that's the idea here, is current is just adding to your speed. And this is true with airplanes too. If an airplane is flying, you know, in calm winds at 100 miles per hour, which is a really slow speed, and it would fall out of the sky. But let's say it was 100, and the wind was blowing at 20 miles per hour, then that would shift all the air you're in, and so you would be moving a total of 120 miles per hour. Okay? Obviously, there's friction and problems with this, and margin of error, but essentially that's what happens. Okay? So when you travel downstream, you're taking your speed and down the stream adding the 2 mile per hour current. And so it's whatever speed you would normally do in still water plus 2 miles per hour. When you're going upstream and the water is falling down the hill and you are climbing up this falling water, your normal speed and then minus the 2 mile per hour current is your total speed you're actually moving. Because if you can paddle at 2 miles per hour and the water is moving this way at 2 miles per hour, you would be going 0 miles per hour uphill because you would just be staying in place. And that would be a good workout, but it's the worst thing. When you're on a bike and there's just a headwind in your face and you feel like you're going nowhere, it's the worst. But then downstream it feels amazing. You're like, oh my God, right? Okay, so let's use this information. And the 2 hints I'll give you is use the speed in still water. As your variable. Rather than using like the uphill speed and then having to take away 2 of the currents, like that just gets confusing. So start with your speed in still water and then add the 2 miles per hour or subtract the 2 miles per hour for the current. Okay, and then let's set up the same table here. So here's my table. Here's my distance, my rate, time, and I'm going to say here's upstream, which means against the current, and then down the stream with the current. Okay, so what's my distance upstream?
2 miles.
Yeah, 2 miles. What's my distance downstream? Yeah, 6. And then the rate is the part where you gotta come up with a variable and figure out an expression. And then the time, you just write distance over rate. Okay, so it's my rate upstream.
X minus 2.
Yeah, exactly, x minus 2. Because speed in still water is my x. Okay, and then downstream is?
X plus 2.
Exactly. So what's my time it takes for my upstream journey?
2 divided by x minus 2.
Yeah, and the other one?
6 divided by x plus 2.
There we go. And then the key for every single equation is in the same amount of time. And that's going to be how I write my equation. I go, oh, sweet. So now I can say this equals this. And what do I set equal to each other?
2 over x minus 2 equals 6 over x plus 2.
There we go. Right, so a cool little physics idea, but the same rate times time equals distance formula, the same types of problems. So, how do I solve it? Dan, you were next, yeah.
You multiply it to x minus 2 in parentheses plus 2.
Exactly, x minus 2, x plus 2 on both sides, because that was the what?
LCD.
That was the LCD. And once we multiply by that, we see, I'm just switching colors like left and right here, these cancel, and we get 2 times x plus 2, and these cancel, and we get 6x minus 2, and then we just solve like normal, right? We go 2x plus 4 equals 6x minus 12 minus 2x minus 2x plus 12 plus 12, 4x equals 16, divide by 4, x equals 4. And then the question said, what is your speed in still water? So your answer would be?
4 miles per hour.
Yeah, 4 miles per hour, because that was exactly what you started with as your x. So your answer would be 4 miles per hour. If this is a point of stress, don't worry about it. This might make up about 5 points out of the 100 on this test. So this should not be something that becomes a large point of focus today, going into tomorrow's test. I would use this time instead to take the practice test and yeah, practice as many problems as you can. I might have enough for everybody. If not, I could just go make a couple copies. Last time I made way too many, so this time I made less. Okay, so anybody who wants a practice test, I have 5 here. So who wants to raise your hand and I'll come around and make it extra copies. Oh yeah, and so don't do number 8. Just number 8. Don't do it. Well, so fine. You want one today?
What about 7?
7, yeah, we're doing 7. Come on, Chris. Or not Chris. Roger. Rogelio. Yeah. 1, 2. Yeah.
No.
Got it. Got it. Got it. Okay, so just 2. I'll go make 2 copies. Okay. All right, and that's it. Okay.